Okay, so welcome back. Today we are having another problem which is very popular. And if you can see the description, like it is intersection of two arrays. We have two versions of this particular problem. One is intersection of two arrays second edition, and then the other one was intersection of two arrays. So both have its way of doing it. So I'll be targeting today this intersection of two arrays version 2, and in another video I will be preparing solution for this. Well, intersection, this is a mathematical concept. Intersection, union, set, subset. So they try to kind of use this in concept of maths and try to understand if we know the meaning of this intersection and how to find intersection between two sets. So over here, these sets are arrays. So num1 is one set and num2 is the other set. And the intersection of these two arrays, if you see, like 2 is common and then the other 2 is common. So actually, what is the difference between this version 2 and version 1 is that here it says each element in the result must appear as many times as it shows in both arrays, and you may return the result in any order. So for example, 2 is coming two times, so and over here 2 is coming two times, so it means 2 and 2. Okay, so it should not be, your answer should not have only 2, meaning if 2 is coming three times, so 2 should come three times in nums2, and that total 3 elements would be there in the final output array. Similarly, for example, to 495, over here 94984. So you see here 4 and 4. So now 1 4 is found, but the other 4 is not found. Like, so only 1 4 is added. And when it comes to the other number, which is 9, you see 9 is 1 and the other 9 is, over here. But since there is only one 9, so that's why we have only 4 and 9. So what simply means that you need to understand that um, the result must appear as many times as the as it shows in both the arrays, in both arrays, right? Create a class which is intersection of two arrays. Okay, now let me add some. So over here I just copied this, and that's good. Now let me write main method, my input, logic, output. So input is, as we all know, it's int array. So in case of like num1 array, which is 1 comma 2 comma 2 comma 1, as I see from the example sample here. And then we have int num2, which should be, sorry, it should be num2, and this should be equals to 2 comma 2. All right. So now this is all good. Now logic says that what we have to do is that again it should return an int array. So result is equals to, now we have to find intersection. So we can make some method which is called intersection. And what I can do, I can pass num1 and num2. Yeah. And then at the end, I have to print out the results. So s out. And over here, I can just say intersections. Okay. And this is, since it is in primitive array, so I will use arrays dot toString, and then I can pass my int here, which is result. All right. So this is a very high level view of the particular problem. Now what we will do is we'll try to understand like what intersection means. Intersection, I think everyone knows. When we have two sets, we have to find elements in set 1 which also exist in set 2. That is called intersection. So when somebody says that you have to do this, what is the brute force solution? I always emphasize in all the videos that whenever any data structure algorithm question or anything is asked connected to problems that can be coded in any programming language, the very first thing which should come in your mind is the brute force solution. And you should not code brute force solution, but instead you should just say and describe the brute force solution and then quickly jumping into the optimized solution, bringing some of the reasons why you would like to go for optimized version. So okay, in the brute force approach, we compare each element of num1, okay, num1 array with each element of num2, okay. And when I say this, I mean it that I am talking about two iterations which are nested. So we pick one element from num1 array and then we compare it with all the elements in n2 array, num2 array. Similarly, we pick another element and all the elements from num2 array. Similarly, third element from num1 and then all elements. So what exactly it's going on? When it comes to the time complexity of this brute force solution, I mean, though we will be getting it, if we found those elements which exist in num1 also exist in m2, if we found during those iterations, we can store them in the result array. That's fine. But the time complexity over here is O of n into m, right? So instead of doing this, can we optimize this particular solution? Yes, we can optimize it. What we can do here, we can actually take some space and then instead of OM cross N, we can just do it in very simple O of M plus N time complexity. How? So let's say if we use this data storage, which is called hash map, and in that hash map, what we will do, we store the counts of each element which is there in num1 array. So let's say we iterate num1 array and then we will store 1, 2, 3 and all the counts of every single particular element in num1 array. And then step 2, we will iterate on nums2. This time we check if num1 contain that element which is there at index I in num2 array. That means it's a number which is a common number which we can add into the result set. Okay, so uh, we iterate over num2 to check if each element exists in the hash map and if it has a non-zero count. If so, we add it to the result list and decrease the count in the hash map. That's pretty much all. That's what we have to do. And this approach will give us the time complexity of OM plus N instead of OM cross N. We just use a small space, which is, for the storing the elements. So if let's say we have M elements in an array, so whichever has, more, I would say, whichever has, let's say M is uh, the array 1 and then N is the array 2. So we are just storing them considering the space complexity with the length of the arrays. So that's pretty much all. Let's go and quickly code this solution. Okay, I create this method. So as I said, we always have to remember that we have to talk taking 1 or 2 minutes in describing the brute force. I think 1 minute is or 2 minutes is more than enough. 2 minutes or 3 minutes you can talk if you want more, and then quickly jumping into the optimized version of the solution. That should be the real way, I mean, to convince a particular an interviewer. Okay, so as I said, I would be using hash map. So here I have map, and then in that map my key will be an integer and my value will also be an integer, and then I say this map as count map. Yeah, it's always very good to know this fact that whenever you are writing creating any variable, you should also name those more semantically connecting to the problem statement, rather than I could have like instead of count map xyz or something like that. But count map sounds very good and it connects me to the problem. So that's why I chosen here meaningful names. So this is my count map which is ready. And now since I need to return a list of integers. So I will also create this and I will say this as result, and this will be equals to new array list. Now at the end, let me do it quickly. Return. You see here the expectation of the solution is in primitive array, if just in case, in order to match the LeetCode. But yeah, I can do quickly. I can return. Okay, so my result is not a primitive array, so I'll just quickly do stream. I mean, whichever way you are comfortable. I know there is a function map to int which can directly convert my numbers in to a primitive array, and then I just can set to array. So it should convert my list of integer strings to a primitive array. Okay, let's go to the main logic. So what I said first we have to count, okay, all elements in num1. All right. So let me do it for, and it's num1, and I'll quickly do count map dot put, and then what I'll do, I need to store the key. So key is my num, and then value is count map dot get or default. So I just use this method, which is very handy because you just not only get um, the default value. Let's say you want to start with 0, and then any other numbers which comes in, you need to add it. So this is a very handy way of doing it. So this what I want to do, and then I would like to copy this again because this is iteration 1, and as I said, in iteration 2, what you do instead of this, what you do, you just write num2, and now we do not have to count, we just check. Okay, we check elements in num2, and we will see if count map dot contains key, which is num. Okay, and one more thing, which is count map dot get, and get is my num, is greater than 0. Okay, if that is the case, then what we will do, we will add this into the result. So we need to add it. So we will add it to the result. So let's add it to the result. So result dot add, and then over here we'll be adding num, sorry. And then what we will do, we will count map dot put, and then over here what we will do, we have to put number, and then we also have to decrease the value. Okay, we have to decrease the value. And why we have to decrease the value? Because as I said, you are first in this iteration adding all the elements and their respective count. Okay, and then the next iteration is where what we are saying, that you have, if let's say when you add a number to the result, we decrement its count in the count map. Why? Because this ensures that for the duplicate occurrences of num in nums2, we don't add it more than it appears in num1. All right. So this is the reason why we uh, just reduce this number. So let me do it. I simply do count map. First is the key, the same number, and then count map dot get, and then num over here. Yeah, and that's pretty much all, I guess. So let me quickly explain you one more time. So count map dot contains key num. Why this? This part checks if the element num from num2 exists in the count map. This count map was populated okay, with the counts of each element in iteration 1. So this check confirms that the num was originally present in num1. Okay, so that is the reason why we do this check. And then we say count map dot get num greater than 0. This condition checks if num still has non-zero count left in the count map. Okay, this ensures that we add num to the result only as many times as it appears in num1. And uh, that was the purpose of this version 2 of the problem. So we always have to add we always have to add we always have to add as many times as it appears in num1. So if num1 has been used up, that means its count is 0. It will not be added again. So that is the reason this condition checks if num still has a non-zero count left in the count map. This ensures that we add num to the result only as many times as it appears in num1. Okay. So if in num1 2 times 2 is coming in, so it will be added 2 times. And when we are adding it, we also have to decrease the count, right? After adding the num, we have to decrease. Otherwise, you will add more. So for example, if in num1 array there are 2 twos, but instead of 2 twos you have added 3 twos. So just to make it sync, so you add all the counts, and then in order to make sure that you match exactly the same count, you have to use always this you have to subtract also. And let me run this problem and then see how it works. Intersection 2 comma 2 is the solution, that's right. Let me change the array, which is 4 comma, okay, intersection 9 comma 4, which should be 4 comma 9. I think it's fine because I remember order doesn't matter in any order. So instead of 4 comma 9, 9 comma 4 is also accepted. So yeah, let me add the time and space complexity. So first let me run the solution to uh, into the LeetCode and see if it works. Control P. I'll paste this solution here, and it is very important to understand that. Okay, this is an extra. All right, we are using hash map here, so I just need to add some of the utilities that I use so that the program runs on LeetCode. Okay, now let me run the problem solution here. Okay, it says compilation error. What's that? Cannot find symbol num1. Okay, it's nums. So we need to just rename the. Okay, I think that's fine. Run. All right, it is accepted. And now submit. And the solution is accepted. Now if we go to this place, let me add the time and space complexity. Time complexity is O of m plus n, and space complexity is O of, again, like you can say any constant like m. So it depends on like whichever. So for example, whichever is the minimum, right? So min of m comma n. Here we go. So that's pretty much all. Thank you very much for watching. I see you in another video.